Hi, Saba.
Hi, Mark, and everyone else.
I'm recording. I've started recording, so if anybody doesn't want to be seen on video, feel free to keep your camera muted. There's a link in the chat for tonight's notebook, so feel free to click on through to that while you're waiting. Hey, Sabo. Welcome.
Yeah. Hi, Mark.
Hi, Madhavan. Welcome. We are recording, so if anybody wants to avoid being on the recording, feel free to mute your video feed. Hi, Nisha. I'm wearing a hat because I have lockdown hair. Really bad. It's just everywhere. I think I'll wait 2 more minutes and then we'll get started. I have the link for tonight's notebook in the chat, and I am recording now. I started a little early because I didn't want to do what I did last week when I forgot to record. So if anybody doesn't want to be on video, feel free to mute your camera. And we'll start in 1 more minute. Okay, let's get started. Thanks for joining, everyone. Tonight will be, as usual, 90 minutes. Yeah, that's no problem, Melody. So 90-minute class. After 50 minutes, we'll take a 10-minute break. And yeah, so if everyone can dive into that notebook, and there's a link for it in the chat, and it's mco.fyi/pi4, following the convention we've been using every week. And let me share my screen so you can see what I'm seeing. Hi, Surya. We're in the notebook mco.fyi/pi4, and we're recording now. So tonight is lesson 4. We're going to go over functions, modules, and just a little bit about a couple other topics like integrated development environments. Make a copy of this notebook like this. Go to, let me blow this up because I always forget to do that. Whoops, wrong window. So is that pretty legible? Yell at me if you can't, if it's not big enough. What you're going to want to do is go to File and then save a copy in Drive for anybody who hasn't done this before. And that will give you your own private copy of this notebook. And then you can use that to do your own work. So we're actually, with tonight's class, we're halfway through the course. Above the line here is showing you the topics we've covered up till now. Tonight we're doing this one, functions and modules. This class I'm kind of doing improvising. Like I'm taking some material I've had in the past and I'm restructuring it, rearranging it, bringing it up to date. And I can sort of make it anything I want. And so what I tried to do was cover like a bunch of fundamental and building block topics through week 6. But then in week 7, I thought we would do sort of a deep dive into 2 different applied areas. The first one being data science. So that's like statistics and data analysis and machine learning and, you know, basically anything you might want to use Python for to get insight out of data. And then week 8, I thought we would dive into using Python in the web and also a little bit about what cloud computing is and how Python intersects with that world. I was originally going to have this class have these group projects at the end, and I just feel like it's such a dense amount of material, it's hard to sort of squeeze that in the 8 weeks. So I thought I would add an optional week 9, which is where we're done with instruction and you form groups or work on your own if you prefer. And you just take a week to do whatever fun project you can think of doing. And then at the end, so the 9th meeting, we would just go around the room and share the projects, see what we learned and what we came up with. And there's no pressure at all. If you take on something really hard and don't make too much progress, it doesn't matter. It's really all about just trying things and learning. So I hope that's okay with everybody. I know I advertised this as 8 weeks and now I'm sort of like sneaking in an optional 9th week. And I made it optional because, you know, I wanted to respect the fact that I originally committed to 8 weeks. But anyway, give me feedback offline if anything about that is not good for you.
Mark,
Yeah.
can you give us a little bit more information about the project, like what sort of project we should do?
Yeah, when we get a little bit closer, I'll have a lot more details on that. But it could be something like deploying a website using Python. It could be writing a command line utility to gather some data from a source, probably a web source, and we would use something called web scraping. Like, let's say you wanted to find the pricing of a particular commodity, something you're interested in. We could write a program that would just go off and grab the prices from websites, and it would just be a good way to show how you can automate many things we do manually through the browser. Another option would be a data science project. So you tell me some data you're interested in, and I'll help you find a source for it. And your project could be to download that source, load it into a Python program, probably in a notebook, because those are really good for doing data analysis, and then creating some graphics around it. So those are just some ideas. But when I get closer to that, towards the end of the course, I'll give you some more concrete suggestions. Was everybody able to install a local copy of Python? So that was one of the homework assignments. And I wanted you to do that because I want you to be able to run Python on your own without having to use the notebooks we've been using as kind of a framework. It's almost like the notebooks are a little bit like training wheels because they just do everything for you. And going forward, I'd like you to be able to use Python independent of the notebooks. We'll still use notebooks for the teaching because I think it's just the best method. But I'd love for you to be able to run your Python programs locally. At the end of this class, I'm going to have you download an editor. And with the combination of a local Python interpreter and an editing program, you're going to be able to do a lot more locally on your own laptop or desktop. So if you're having problems in that area, it looks like people are saying, yeah, they were able to install Python. And Python 3, I don't know if I made that clear. Python 3 is definitely better than Python 2. And so for anybody who hasn't done that yet, or anybody that ran into trouble, just let me know. Email me, and we'll sort it out. As far as the groups, I thought it would be fun to have groups for the project at the end of the course, but I also thought it would be nice to have study groups. So in case you're having a little trouble or wanted to put your heads together on some problems, you'd have somebody to reach out to. So I created a little spreadsheet that I'm sharing right here. I gave everybody in the world access, write access. So feel free to form groups along these rows. Just put your name down. If you have people like you want to work with, just put, make your preformed group or whatever, but it's really there for you, however you want to use it. And there's a short link, like there always is, mco.fyi/groups. So check that out, no rush, but feel free to take advantage of that. And with that, I think we'll jump into the topics. Before I do that, did anybody have any questions about last week or the homework or anything else we've done in the past?
Mark, this is Shubha here.
Hi.
So I had a question last week regarding the for loop, the decrementing of for loop. So it seems like I figured that out. So I just figured out like the for loop accepts 3 parameters. The first one being the initial number. The second parameter is the ending number. And the third parameter is the increment or decrement operator.
Yes, I think you're referring to the range function, right?
Yes, yes, Mark, referring to the range function.
Yeah, so the range function is like, as a review, we would typically say for I in range, and we could just give it a number 10 and then print I, and that's going to give us 0 through 9. Or we could give it a starting value, like we could say 3, 10, and that will give us 3 to 9. Or we can also give it an increment, like 2, and that means go up by 2s. So that's 3, 5, 7, 9. We can even give it a negative increment. This isn't going to work very well because we're saying go from 3 to 9 by negative numbers, which makes no sense at all. But we can say go from 3 to 1 by negative 1s, and we go 3, 2, and we stop at 1 away from the end value. Does that help, or did I miss the question? Sounds like maybe it helped. I'll assume it did, but yell at me if it didn't. Tonight we're going to learn about functions, and that's actually one of the most important things, not just in Python, but in all of computer science. And that's because everything is built on other things. Everything is built out of functions. Functions are the basic building blocks of software. Up to this point, we've just been writing code, and it's always like this monolith. And that's fine for little tiny programs like we've been playing with. But when you get into bigger programs, you really need to break it down into chunks. That makes it more manageable, especially when you're writing code with other people. In an ideal world, we would just take like these units like Lego bricks and snap them together to build things. And that would buy us a lot of advantages. Some of the advantages are abstraction. And if you think about how you build a house, no one actually does every little detail in the house, right? You have somebody who designs it, you have an architect, you have like a contractor who gets all these people to do their detailed stuff like carpenter and electrician and all that stuff. And that's kind of what functions are like. It's like you don't need to understand how to actually print something. You just call the print function and it does it for you. So you're just leveraging somebody else's expertise. The other big value of functions is reuse. If somebody's already solved a problem, you might as well just reuse it. Why reinvent it from scratch? There's an example here, which is like you can count the number of words in a string this way. So let's take a quick look at this code and let me blow it up a little bit. So this sets meister equal to the string. This is a test. Let me get rid of that space. Then I have a variable called count, which I set to 0. And now I'm going to loop through the characters in meister. For I in meister, if I encounter a space, then I must be at the end of a word. So I increment count by 1. And at the end of the loop, I increment it by 1 more because this last word ends right up at the end quotation. There's no space to look for at the end. So I'm assuming that's the case, and I'm just adding 1 more, and then I print the number of words. So this should give me 1, 2, 3, 4 words, and it does. But there's an easier way to do this. You can just call the string method split, which splits it into tokens to separate it by white space, and then I can take the length of that. So with this approach, it's just a lot less code, but more importantly, it's more reliable. And can anybody guess why this is better or more reliable than my version? I won't wait too long because you're a quiet group.
Less coding and more clear to read.
It's easier to read and it's less code, absolutely. The other reason why this is better is what happens if I put a few extra spaces in this string? This code thinks that every time it sees a space, it's reached the end of a word. But in this case, all those spaces it's going to think are extra words. So this 4-word sentence, all of a sudden my code thinks is 7. If I do the same thing here using the system version of split, it still knows there's 4 words. And why is that? Because a million people use split and have been for years, and all of the bugs have been fixed. Whereas this version just came into existence a few days ago, and I didn't think through all the edge cases. And so this reuse principle is not just taking advantage of other people's work, but it's taking advantage of all the quality that accrues when code has been optimized over long periods of time and used by many people. So more justification for functions. The first approach I did here is great for learning. So don't ever feel like, oh, I shouldn't write code that already exists, because actually you will learn a lot just by trying to reproduce some of the system stuff. But if you're actually trying to get real work done, I strongly advise using the stuff that's already there and very solid and reliable. Modularity is another concept here. For example, Google has billions of lines in one single repository, and no one can keep track of all that code. No one really understands the entire piece. And by dividing it into chunks, it becomes manageable. You just have to understand one subset, and hopefully one small subset that you can get your head around. And maintainability is also really important. And the idea here with functions is that you don't have to keep repeating or copying code. Sometimes you'll see a piece of code and you'll say, I want to do that over here, and you'll copy it. And then you'll say, I want to do it over in this other place, and you'll copy it. And before you know it, you have 10 copies of some code. And that's okay, but then you'll decide there's a bug or you want to enhance it in some small way, and you'll have to go find those 10 places where you copied it to make all those fixes. What functions let you do is put that code in one place and just reuse it by calling it. And so then if you fix it, it's just magically fixed everywhere. So that's another really important advantage. All of the problems we've talked about are solved to some extent or more by functions. And we've already seen several of them, like print, input, inth, len, range. We just looked at range. What we haven't done yet is define our own functions. And that's really where the power comes in. We can build our own functions, and they can use other functions. They can use system functions. So we can sort of make these arbitrarily complex Lego type structures using functions. So that's why it's so important. Syntactically, it looks like this. you use the def keyword, and that's just short for define. Then you give it a function name, and that has the same syntax rules as a variable name that we talked about in lesson 1. You can specify 0 or more what we call arguments, and these are just placeholders that take on values when you call the function. You can have an arbitrary and optional string after the function, the def statement, and this is called a doc string, and it has some special meaning to the Python interpreter and a few other tools, and I'll show you an example of this rather than try to explain it now. But it just helps you document the function, what the function does, and that's why it's called a doc string. And then you have one or more statements that are indented. And just like with if statements and loops, the body of a function in Python is defined by indentation. So it has to be indented. And when the indentation stops, that's no longer part of the function body. And every line that's indented has to be indented consistently for it to be part of that function. Just like everything else we've seen with blocks, while loops, for loops, and if statements. I think I covered the rest of that. So doc strings, as I said, just a string right after the def line. It's usually triple quoted because it may be multiple line, but it could be single quoted. It's just as long as it's a string, Python will be happy. It's not required to make the function work, but it's a nice thing to do. Editors like Visual Studio and this notebook environment will use those to tell you if you start typing a function, they'll tell you like what you can find out about it through that doc string. And you can also use the help function. It will automatically populate that based on the doc string. So it's a good thing to do. Here's an example, function definition. So this function is called fact10. If you remember what factorial is, because I have triple quoted string here, I can make this multiple line. And I can say print the factorial of 10. That's what this function does. And I can say factorial is defined as 1 times 2 times ... all the way up to 10. I should say factorial of 10. And before I jump into that code, I'm going to run this, and nothing happens. And that's because all I did was I defined a function. I didn't actually invoke or call the function. So now there's a new function named fact10, and it's free for me to use, but I haven't done anything with it yet. One thing I can do with it is ask for help about it. Even though I haven't used it yet, I can say, give me help about it. And you should notice that this looks familiar, right? I just added this. So that's a good example of what the doc string is all about. Just to show you it really is changing, not cheating here. There's my yay. So that's what doc strings are for. Let's actually see what this function does now. So it starts with num equals 10. That's just setting that variable to a limit of 10, so we don't have to embed the 10 somewhere in the code. We set this accumulator called fact. It could be called total or result or something like that. And maybe that probably would be a better name because fact is so close to the function name. I'm going to change it to result. So we'll say result equals 1. And then we're going to range for I in range from 1 to num plus 1. And because we always end our range at 1 less than the final number, we're going to stop at num plus 1 minus 1, which is num, or 10. So this is going to actually go from 1 to 10. And each time through the loop, it's going to multiply fact by I. This syntax, as we've seen, is short for fact equals fact times I. And now I need to change fact to result because I changed it above, and if I'm not consistent, I'm going to get errors. And of course, I'll print the result at the end. And the reason result has to be initialized to 1 is because we're multiplying. If we set that to 0, we're going to end up multiplying 0 all the way through. So let's try running this. And it does not like this statement. I think it's because of the dot right there. One quirk of this notebook is if you type 2 spaces really fast, it thinks you want a dot, which does not make sense to me. But anyway, that should help. And it prints out nothing because, once again, I just defined a function. I didn't do anything with it. Now let's come down here Make sure the help data is still there. It's cleaned up. And now let's actually run the function. So fact 10, and we get the factorial of 10. So that's nice. We created a function. We had a nice little for loop inside the function. We printed some results. But this is a very limited function, right? I mean, nobody would ever really want a function like this, because how many times do you want to know the factorial of 10? Like usually you want the factorial nature, but you want to be able to have the flexibility to specify which number. And that's where arguments come in. So instead of just deft fact, well, here I had deft fact 10 and no arguments, just an open close parenthesis. I'm now defining my function with something in the parentheses. And in this case, it's just one name. It's a variable, and we call it a parameter. And this num will take on whatever value is passed when someone calls this function. So the rest of this looks pretty much the same. I'll clean it up like I did the other one. Result. But now when I call it, I don't just say fact, open, close. In fact, if I do that, I'm probably going to get an error. Python's going to tell me something like fact, missing one required positional argument num, which it's a pretty good error message by my standards. So that pretty much tells me that there's an argument missing. So I'll give it an argument of 5, and I get 120. And if I do 10, which I was doing before, I get the same number. So now we have a general purpose factorial algorithm which we can use to get the factorial of any number. And this is where these parameters and argument passing comes into play. You can take a general piece of logic and you can make it support any specification you can provide through the interface you define. So we talk about parameters and arguments. I probably covered this already, but the variables that we define in the function, so in this case num, are considered to be parameters. And they're parameters because they take on values according to some input. So in this version of a function down here, def sum a, b, c, a, b, and c are parameters. The values that are supplied by the caller we call arguments. So in this code, 1, 2, and 3 are arguments. In the example we did right here, num is a parameter, as I said, and 10 is an argument. And the difference is the caller and the called code. That's the main distinction. Functions can define any number of these parameters, including 0, as we've seen. Multiple parameters are separated by commas. We saw that. If you pass the wrong number of arguments, you'll hear about it, and we saw an example of that as well. Now, another important thing, these parameters, or these arguments, I should say, are ways to pass things into a function, but sometimes you want to get something out of a function, right? A lot of the examples we've been showing have been printing the answer, like this fact function prints the result. But in real programs, we usually don't want to print the result because we don't want to just blast stuff to the user's screen. We want to usually let the person who called, or the code that called the function, get the answer and do with it what they want, present it in what way they want. They might not even want to display it. They might want to write it into a database or present it on a web page or something. So a much more commonly used technique with these functions is to return the result rather than printing it directly to the user. And return just means whatever value we want, we can give back to the code that called the function. So here's a version of fact that is pretty much exactly like we had before, except instead of printing the result, it returns the result. And the way we would call this function is now we don't just call fact 5 because it's not going to print anything. It's going to return something. So we have to sort of catch the thing that's returned. And the way we do that is we simply assign it to a variable. So if we say f equals fact 5, we'll get the result. It'll get stored in the variable f, and then we can print it if we want or do anything else we'd like. The way that functions return this value is through the return statement. You just saw that right here. It causes two things to happen. One is what you already saw, it returns a value back to the caller. The other thing is it ends the function, and control is immediately returned to the place in the code that called the function. You can have as many return statements as you like, including none. if the caller wants to do something with a return value, it needs to use it or save it. If you just call, like, so input's a good example. Input prompts the user yes or no in this case, and returns whatever the user provided. And if you don't use that in an expression or store it in a variable like I'm doing here, resp equals, it just disappears into the thin air. So like if you had a line of code like this, input yes or no, input's going to return something and you're not assigning it anywhere, so it's just like lost, it's just gone. Is there a use case for that? Yeah, if you wanted to just like do one of those, like hit the enter key to continue, you could do that with the input and not save the result, because you're just really trying to stop your program and wait for the user to do something. But that's about the only case I can think of. Most of the time you really want to know what the input was, so you'd want to save it in a variable. You can return multiple values, and you do that with comma-separated values in the return statement. An example is divide. Let's say you have a, like a number, a dividend, and a divisor. So that's like x divided by y. And you define a variable called quotient, which is dividend divided by divisor. That's going to be a floating point. And then the remainder is dividend modulo divisor. So if you wanted to give complete precision to the caller, you would return both of those quantities like this with two values. And the caller can capture those by assigning to multiple variables like I'm showing here, quotient and remainder equals divide 109. Let's see if this actually works. I guess we need to define the function first. Should have put this in a code cell, but let's see how it goes. Yeah, looks like it worked. So you can return and you can catch the return values with multiple variables, and hopefully that gives you a sense for the basics of defining your own functions. I have a challenge for you here, which is about different functions we've seen and different categories. I'll leave this to you for homework, but it's basically like, can you think of a function we've already seen that takes no arguments, that takes one argument, etc. And if you open this cell, it'll give you the answer, but try and see if you can answer without checking first. And that takes us to namespaces. I'm going to pause for a minute and see if anybody has any questions. Don't see anything in chat. Just jump on the audio if you do.
Mark, what's the main difference between the print and return state function?
Between the which and returns?
The print and return. Print.
Print and return. Okay, that's a good question. Let me try a quick example that I hope will explain that. So I'm going to define a function called add, and it takes two quantities, x and y, two parameters, I should say, x and y, and it prints x plus y. So if I call this function add 7 and 8, it prints 15 to the end user. Now, if I was writing a program where I needed to know what the sum of two numbers was, and I need it for some internal reason, like let's imagine you're depositing money in your bank account. And so I want to add your current balance with the amount you deposited so I can find out what your new balance is. And then I want to store that balance back in your account. I don't really want to print anything, right? Especially if it's sensitive information like your bank balance. So if I'm writing this code and I want to figure out what to store in your new bank balance, I would say, new balance equals add 7, 8. I'd like to capture the value and put it in that variable. But the problem is add doesn't return anything. It just blasts it to the console or to the end user with this print statement. So a more kind of friendly way of doing this would be just to return the x plus y. And we don't really need the parens. It would work fine. But now if I do this, there's no output. Whatever would have, gone out in the print statement, I've returned to the caller, which means it came back here and I stored it in new underscore balance. So if I now print new underscore balance, I should see the sum is stored in there. And of course, I don't want to print it because I just told you it was some sensitive bank account stuff. So instead I would say, you know, write database, whatever person's account has a new balance of new balance. You know, I would write some code that would manipulate the world with this value I got back from the function. Does that help?
Yes, yes, thank you.
Let's get rid of this. So I'll let you do the challenge on your own. I want to talk a little bit about namespaces because this can get pretty confusing. A namespace is just an abstract collection of variables that have a particular context. And that's a very abstract statement in its own right. But a way that I like to think about it is, imagine you work for a company and the company has these ID numbers, like, you know, like an employee number. And the employee number, the set of employee numbers in my company is totally different and independent of the set of employee numbers for your company. And my ID number doesn't make any sense in your company. It might not even be syntactically correct. Somebody might already have it. It's just that there's no relationship. And that's what namespaces are like. And when I say namespaces, I mean the names in the environment, the variable names, the function names, the module names, all the names are part of a namespace. We've seen an example of this when we say import random and then we start using it. Random has its own namespace. And to access names in that namespace, we qualify it by saying random dot and then something else in there. If you neglect the random dot prefix, then you're referring to what's called your global namespace. Now the global namespace is all of the names, and that's again variables and functions and anything else that you've defined in your program. So if you just do count equals 0, you now have a name in the global namespace. While true, Meister just defined a new name in the namespace. And one of the cool things about Python variables is you don't have to declare them ahead of time. If you just assign something to them, they exist. And Meister is now part of the global namespace. This rec variable, global namespace, count we already defined, but all 4 of those or 3 of those variables reside in the global namespace. So what's not in the global namespace is something called the local namespace. And the reason I'm introducing this in this lesson is because it's related to functions. Whenever you define a function, you have a new kind of namespace called the local namespace for that function, and it supersedes the global namespace. And what that means is that it's sort of layered on top of the global namespace. So the global names are still visible inside the function. But if there's a conflict, if you define a name in the local namespace that has the same name as the global, it overrides it and it takes precedence. Also, local namespaces, and in turn the variables you define in a function, are transient. So they come and go. They don't exist outside the scope of a function. So here's an example of a name that supersedes in the local context. It supersedes the global context. So I create a variable equals 1, var equals 1. This is now a variable in the global namespace. And then I define a function, and I'm using that same name and setting it to 2. And without knowing all this business about local and global, you might think I'm overriding the global variable, but I'm not. I'm creating a new local variable, setting it to 2. And if I refer to it, I'm going to get the local version. So this is where local overrides global when there's a conflict. But up to this point, I haven't really done anything. I've just defined a function. So in fact, if I comment that line out, I define the function and then I print the global version and I get a 1. If I instead uncomment that and call that function, I get a 2 because the local variable has superseded the global variable. But it only overwrote the local copy. When I returned from the function and fell through to this print statement, I can still access the global version, and it still exists, and it still has its original value. So that's the whole business about local superseding global. There's also this transient thing I mentioned. And so the example I wanted to show you here is there's no global here called x. I just define a variable x locally, print it, and then I call the function and the function prints it. And then I look for this global variable x. And I was not expecting to get all that information. I think it's probably because I had something called x before. So let me try something different. Let me try something I know won't clash. Yeah, so local var gets printed out. But when I look for the global var, it says name x2 is not defined. So there's no global variable by that name, and the local variable doesn't bleed out of that function. So after I'm done calling that, I can't refer to it. It doesn't exist anymore. Another way of demonstrating that exact same thing is in this example where I had var and I was reusing the same name. Imagine if I had var1 and var2. And this will work fine. It'll say, you know, local, sorry, var12. Oops. Try that again. So this says local var is 2 and global var is 1, and we know why that is. But what if I refer to the local var outside of the function var2? And our name var2 is not defined outside that function. So hopefully that shows you what I'm hopefully not beating this too much to death, but that's what namespaces are all about. And I'm getting through today's class like really fast, so maybe I'll have to figure out some more material to add during the break. But the next topic is modules. We saw a version of this earlier when we were importing things. A module is a file of reusable Python code. The module's name is basically the file that it's stored in without the .py extension. So the file would be like module.py. For example, random, there's a file somewhere, random.py. And when you want to use it, you just say import the part before the .py, which is implied. So you'll say import and then a module name. And with that module comes a namespace with all of the functions and variables in that module. This is probably a little bit esoteric. This is about where Python finds the modules from. And for our exercises, we're just going to assume the modules in the same directory. So don't need to worry about that too much. But there is a way to tell Python where to go look for modules you're including. So namespace, as I said, is referenced by saying the name of the module dot variable or the name of the module dot function and then any arguments you want to pass. An example that we've seen already is random.randrange. You'll also see this syntax, from module name import something. What this is doing is said, instead of when you do an import, you have access to a bunch of things, but you still have to qualify the module name to get to them. So if I say import random, I still have to reference random dot whatever to sort of peek into the random module. When you do from module name import star, that says bring all of the names in module name right into my global namespace. So now I don't have to say random dot. I can just say like here I was using random.randrange, and now I can just say randrange. It's right in the global space. I think maybe an example of this might help. So let's use random, import random, and random has a bunch of methods, and this is where the notebook and the IDEs will typically give you help and show you all the things you can call on random. Random has a function called random, so it's random.random, and all that does is returns a random number between 0 and 1. The reason why it's random.random is random is the module name and random is the function. So random.random, we should get a nice random number and a different one, hopefully, every time we call it between 0 and 1. Now, if I instead said from random import star, I no longer need to qualify it because I've just put all of the contents of random's namespace into my global namespace. So now I can just refer to random as if it was something I defined in my own program. And by the way, I'm hovering over it and I'm getting this nice usage information here. And that's because I lost it as I tried to use my fancy highlighting feature. That's because there's a doc string. Whoever wrote the random function gave us this nice doc string. And so this should work now without qualifying random. Now, one bad thing about this technique is I've just polluted my global namespace with a huge number of names. And to tell how much that is, I could go back to this. Actually, I would have to go back to random, and then I would say random, whoops, dot, I'm not sure why I'm not getting that. Maybe it's because it's having, yeah, I think it's probably that. Okay, not going to worry about debugging this, but the bottom line is the random module has a ton of names. And if you already had a name in your global namespace that matched that same name, you've just overwritten it if you do use the from syntax. So if you do this, and in fact, we can even see that. Let's prove that. I can say def random. I've got my own little random function and it prints 7. It's not a very good random function, but I'm happy with it. So if I run it, that just defines it. Let's actually run it. And I'm happy. I've got my random function, and every time I run it, it says 7. And then I do from random import star. And now I call my random function, and I get the one that came from this thing. So this is why you want to be careful about these sort of this overloading of your global namespace. And one way where you can, it is convenient if you just want a certain function and you don't want to keep saying random dot or module dot over and over again. It's convenient to, like a happy medium is to import the specific names you want. So I can say random, and now I'll get the random function, but all the rest of the stuff in the random namespace, like there's a function called randint, won't be available. Now it's going to be available because I previously imported the whole thing, and these notebooks are stateful. So it's remembering, you already have all of random in your namespace, but I'm going to show you how I can undo that. I can say restart runtime. And this is a good thing to know. Anytime the notebook gets kind of confused on you or takes a long time to finish something, just restart the runtime. And now if I run this, I'm going to get rid of this thing because I don't think it's relevant anymore. But I'm just going to import random from the random module and try to access it. And this should work. I'll do a print. And then I'll do a randint, and it should say that doesn't exist. So name randint is not defined. If I really want to access randint, I need to dig into the random module with the qualifier random.randint. And that actually doesn't exist either. I need to either import random, and I can do this, or more reasonably, module object not callable. I think it's because I imported random after. I'm getting into the weeds here, but the bottom line is an even better way to do this is if I know I want randint, I can just include that like that, and then I can reference it as if it's in the global namespace. giving it the parameters it wants, but at least I'm able to access it. So hopefully that explains what the difference is between import and from. This is review from about what I just said. All duplicate. Yeah, so I'll let you read over this for homework, but one thing to know is you might wonder, like, when should I use one or the other? And I think it might be obvious by now, but it's generally best to use import as a rule because there's less risk of these name clashes and surprises, and it makes your code more clear. Occasionally, you'll use a function so many times that you just get sick of typing module dot function, and it's worth importing it directly, not just because it saves you keystrokes, but it's also more readable, makes your code more readable. And in that case, it's worth doing the import from with a specific name. But I would generally avoid the from import star, and just be careful when you're doing this sort of thing. So we're at 10 of, and I think we'll take a 10-minute break. I'll figure out how to pad this lesson because we're coming up towards the end. So I actually can spend more time on the example programs, which is probably good. So anyway, let's take a break and regroup in 10 minutes.
Hi, Mark.
Yes, hello.
Yes, hello. Okay, so please, what's the difference between a module and a library?
There's no actual.
Actual.
So, sorry, there's a lot of echo here on my end.
Okay, so I mean, what is the difference between a module and a library?
Yes, yeah, I got the question. I'm just going to mute you temporarily. Oh, you already did. Okay. So, a module is a very strictly defined concept in Python. It's a collection of functions and variables that one can import into another program. A library is more of a fuzzy concept. You'll hear people talk about Python libraries, and typically it will be just a collection of resources. It might be a collection of modules, it might be some modules and some data files. Sometimes people will use the two interchangeably, but strictly speaking, module is the word for the Python entity of sharing code, and library is more of a fuzzy term for sharing code that might include a module or might even be one-to-one with a module.
All right, thank you.
Mm-hmm.
Mm-hmm.
Pick up again in a minute. Okay, let's keep going. Now that you've all installed Python, you can use Python locally, but it's not that convenient because in order to do so, you have to open up what we call a shell or a command processor. And this looks different on Windows and Linux and Mac, and requires you to know a bunch of cryptic syntax like ls and stuff like that. And to run Python, you would type the command Python, and you would get this interactive prompt where you can just enter random Python syntax. Or you can have a Python program. I saw this before, where you can say Python and then the name of the program. In any case, you're kind of bashing around at the command line. You need to know all these magic incantations, and it's not all that convenient. So the next thing I'd like you to do for next week is to install an IDE. IDE stands for Integrated Development Environment. A simpler term is just a code editor or a text editor. The difference is we usually call them IDEs when they have all these fancy features, like when you put your mouse over a name, it tells you what name it is or what kind of thing it is, and it lets you finish the, select from a set of functions or argument names or whatnot. Also, IDEs usually have a built-in debugger, so you can interactively watch the variables change, and all that stuff's great. But what I really just want to have is an environment that's really easy for you to write programs and run them without having to know all this command line stuff. There are many popular IDEs or editors, and the basic idea is they're there to help you write and run and debug your programs. The one I like best and the one I use mostly is called Visual Studio Code, VS Code people will call it. It's open source, it's a Microsoft product, but it's free, and so you can just download it and run it on a Mac or a Windows machine or a Linux machine. Really nice environment, very powerful. It's a bit more advanced, and so for our course, what I'd like to recommend is we start with something called Mu. I'm not sure actually how to pronounce it. I think it's probably Mu, like the Greek letter. The reason I like this one is it's just really simple, really great for beginners. And you can always graduate from Mu onto Visual Studio Code. But if you're comfortable with VS Code or you've used it before, feel free to just jump to that one. So it's not a hard and fast rule. I'll show you Mu interactively in a minute in one of the example programs. But first I want to do an example that doesn't require an IDE. And the idea here was I was going to create a list of all the students in the class, and I was thinking it'd be nice to generate random groups, study groups. And I threw that idea away because I thought it might be better to just let you self-form the groups, and I gave you that reference to the spreadsheet earlier. But I still think it's an interesting problem. If you have a group of things, if you have a list of things, and you want to break them down into groups randomly, how would you do it? And it turns out it's relatively straightforward in Python. This is a little bit longish. I think I could probably get it down to probably a dozen lines of code. Right now it's about 20 lines, but this is a way to do that, and it doesn't take too long, and I think it'll reinforce some ideas like functions and loops and prints and things like that. So first we're importing two modules, string and math, and then we're specifically getting access to one function within the random module called sample. Now sample takes a population, this is a collection of things, and it says give me a random k of those, where k is a number. So like give me a random 7 out of 1,000 things, any random 7. So you can sort of start to see how that could be a powerful function to use if I'm trying to divide up the students into groups. So I've defined a function called groups, and I want to pass it 2 parameters. And these parameters are, well, I should say I'm passing it 2 arguments when I call it. But these 2 arguments are the collection of things. I'm calling this the student list. and the size of the groups I want to create. So this is sort of like a free design variable that you get when you write a function. You get to decide what are the ways in which I want the person who uses this function to be able to tailor the behavior. I could have just hard-coded group size to 3, but that could easily imagine whoever wants this to be able to change that. So I included that as one of the parameters here. So I take the student list and I turn it into a set. I haven't told you what a set is yet, so I'm going to ask you to suspend any discomfort that you see with this and just tell you that that's sort of a compound type in Python. We're actually going to learn about it next week. But it's a way to take that student list and turn it into a collection of students. And I'll store that in a variable called students. I have a print here for debugging. I don't want it right now because it'll just clutter things up. Actually, I'll turn it on so we can see what's going on with the first time we run it. And now I'm going to say for I in range, I want it range over the number of groups. Now, how do I get the number of groups? Well, the number of groups is kind of going to be the number of students divided by the group size. So len students gives me the number of students in the student collection, and I divide that by the group size. The problem is that's going to give me potentially a fractional amount, right? Because there's no guarantee the number of students is going to be evenly divisible by the group size. So I use something called the ceiling. That's a math function that returns it rounds up the value to the next higher integer. So if it's 6.7, it rounds it up to 7. This just forces me to have as many groups as I need, even if the last group doesn't have a full complement of the group size. Okay, so every time through the loop, I'm going to ask for k, but I'm taking the minimum. I'm making k the minimum of the group size and the length. Now this will become clear when you see that I'm reducing the student list every time I allocate a group. But let's put this on hold for 1 second. We'll come back to it in a minute. I say group equals sample of students and k. So for the most part, assume k is group size right now, the value that got passed in. So this is that sample function I told you, and it tells Python, give me k students out of this list. I don't care which ones. I want random k students out of this list. And store that in group. I'm going to print the group. And then for each member in the group, I can get that by saying for j in group, remove those people from the student list. So this is saying anybody I just allocated in a group is allocated. They're assigned. I don't want them in the pool of students that remain to be assigned, so I'm removing them from the student list here. Now, eventually, I'm going to remove group size students each time through this loop, and there's a decent chance if the student list is not a multiple of k, exact multiple of k, there's a decent chance I'm going to have some left over. And I don't. And let's say k is 5, and I pull 5 out, 5 out, 5 out, and I'm left with 3. I don't want to then ask for 5 more. I want to ask for 3 because now the size of the whole collection is bigger than the sample size, the group size that I was asked to get. And that's what this thing that I was saying we'd come back to is all about. It's saying I want k to be the group size unless it's bigger than the number of students that are still left in the pool, the free pool. If that's actually smaller, if the number of students is smaller than the group size, then I want as many students as there are in the last group. So I set k according to that, and now I know that k value will be reasonable all the way through, even when I get to what the left, the ones that are left that haven't been assigned yet. And then I go through here, I generate the groups, I print them, and I remove them from the pool and just keep going until I fall out of the loop. So let's try it with this. I have a list of names, and I will I'll pass this list of names and I'll ask for groups of 3. And first I'm getting the full list of students because of this print that I uncommented, and I see it's exactly the list I would have expected. You might notice it's in a different order, and that's because sets are unordered data structures in Python. There's no guarantee on the order. We don't really care because we're just randomly grabbing names, but if you actually check, everyone that's in this set here is in this list and vice versa. So that shows us that, you know, the data we're passing is actually getting into the function. Let's comment that out just to clean up the output. And then we see the two groups rather that it formed. Now, if we run this again, because sample is coming from this random module, we should get a different set of groups. And just to be sure, the second one was Mark, Alex, and Dina. Let's run it again. And Maya, Alex, and Dina is the first group. So you see it's actually randomly choosing things. Now, what if we have spillover? Like in this case, the number of students was exactly divisible by the group size, but let's add Bob and Carol. So there should be 2 left over in a non-full group, and that's exactly what we see. So this tells us it's working right. If I'd like to test this just for a bigger group, I could do something like this. I could make a set of groups around the ASCII lowercase alphabet. What this will do is create a set of students where there's 1 student for every letter of the alphabet. So it should be a set with 26 values like we see here, and they're randomly arranged. Let me comment this out. And if I say I want groups of 3 from the alphabet, I can do that like this, and then I get my groups of 3. And because 26 has a remainder of 2, I have 1 group left over that's 2. I could say give me groups of 5. Yeah, so you see how this works. The function gives me all the flexibility I need. I can specify the community I want to draw from, and I can specify the size of the groups I want to form. So hopefully that was clear. If not, take a copy of this code in your notebook and try playing around with it and see what you can do with it. The next example I wanted to show you is going to highlight this program I mentioned called Mu. So go over to that. I'm going to first copy this code, and I'm going to stop Mu just to give you a sense of, let me close these files. And I'll just show you how it looks from the beginning when I start it up. So it has a very simple user interface. Looks a lot like some of the things you've seen before, I'm sure. You can say new, and when you configure Mu, you can kind of tell it what sort of setup you want. Typically, I'll use this Python 3, which is just a standard Python application. But for this actually, I'm using web, which gives you a default set of code for a web server. But I'm just going to actually wipe that out and replace it with the code from my notebook. So that's there. We'll come back to this in a second. I can say save, and it puts it into Mu code, and I'm going to call this web.py. And then let me get this one other, I think I told you to call it webserve.py, which is fine. And then there's one more file we're going to call greeting.html. So let's go back. Let's create a new file, and let's copy the code that I just got, and let's name it greeting.html. I didn't want to do that. I really wanted it to be greeting.py. Okay, let me try one more time. Rather, greeting.html. So I'm not sure how much you all know about the web and HTML and all that stuff. And coming up in lesson 8, we're going to dive deep into the web, and we'll talk about all this stuff. But for right now, it just all you need to know is that HTML is the language of web pages. It's the way you express a web page so that when your browser fetches it over the internet, it understands how to make everything look for you. And so we're defining a little web page here It really doesn't do much at all other than say, hello name, how are you? And the name variable comes from the URL that you visit when you come to look at this web page. So this is sort of static content. It's HTML content. It's not running a program, so to speak. It's just some markup, we call it, which is used to render an appearance of a web page. It's not really a program per se. So let's go back to this, because this is the program. So this is Python code that actually implements a web server. So a lot of people, when they first see this, they're surprised, because like a web server sounds like a big, impressive piece of software. Well, this is a really simple web server, but it's kind of doing what web servers do all over the place. It has from a module called Flask, and Flask is a very popular package for building web applications in Python. From that module, we import two functions, Flask and render template. You can already guess probably what render template is going to be used for, because we just built that greeting file, which has got an entry for a name as a template. Anyway, we create an app. So this app variable creates what's called a Flask object. And then we have these things called routes, which are simply what you specify after the URL to this website and what behavior you want when someone visits that, that route. So if you specify /hello/something, then we render the template that we see in greeting.html with the name replaced by the name in the URL. I know that sounded complicated, but I think it'll be more clear when I actually run the program. And if you specify route /, meaning you don't put anything after the URL, you get just a basic template, a basic kind of boilerplate web page. So let's actually run this, and it should run locally for you. And it says running on, and you get this address and this port. So if you copy that URL and pop it into your browser, you get this nice hello from you. It's telling you a little bit about what you're looking at and so on. But I didn't put anything after the URL, so it took this route, the / route. I think I might even be able to put an explicit / there, and it should work as well. But if I look for the other route, if I want to get the hello whatever, I can give this URL, hello/people. It says, hello people, how are you? Or I can say hello world, and it says, hello world, how are you? So you get the idea. The application looks for a route. In this case, it matched this route, the hello route. It took the name from the URL string and passed it into this render template function, which said, open this HTML file and substitute name for the value that came in on the URL with name. And this greeting had that name substituted for it when the web page was downloaded to the browser. I don't necessarily expect all that to be crystal clear. I'm like glossing over a lot of stuff, and I'm also talking about several things I haven't explained. But I mainly just wanted you to get a sense of what an example web server can look like, how simple the code can be. Granted, it doesn't do anything terribly impressive, but I also wanted you to get a sense for what this new environment looks like. I see there's actually a browse button. I could have used that instead of copy pasting. So I have some things to learn about Mu as well. But it's a nice little environment. I think you'll like it. And that's kind of concludes the example programs I wanted to share with you. For next week, if you've already been reading all along, you're actually caught up, because the functions assignment I gave you, functions and modules to read last week, was kind of a precursor to this lesson. So you can take the week off of the book if you're caught up. If you haven't read the first 3 chapters yet, this is a great week to catch up, because there's no new reading assignment. As always, make a copy of this notebook and work your way through it. Do the challenges, do the homework. For next week, install the Mu IDE that I just showed you, and email me if you run into any problems. This week's homework is a little bit tougher than the last couple weeks. So just let me know if you run into problems. One of the fun things about this week's is now that you know how to define functions, the questions are basically saying, create a function that does this, create a function that does that. And then the cell after where you, so you'll add your code here. You'll say def sum, whatever you want to do. And then you'll run that, however you define it. I'm putting just a blank function in here. And by the way, the word pass is a special name in Python. It means don't do anything, but it lets you put a statement there. If you don't put a statement there and just say def and don't say anything, Python gets unhappy. So if you ever want to just have a placeholder, you can say pass. It defines this function called sum. And then when you've written your function, you can say run this cell to test your code. And so I've written some code that will exercise your function and tell you if things are good or not. And my sum function, which does nothing, fails miserably. If you write a function that passes all these tests, you'll get this happy test pass. I should put emojis or something in here. But anyway, that's the way that's going to work. And the last thing is I wanted to show you this site called CodingBat, which I really like. It lets you do interesting things like it has these challenges. Like you just click your way through. It'll give you a challenge like given a string, return a string where for every character in the original, there are 2 characters. So let's just write that right now. Double char. They've given you the boilerplate for defining it right there. So the passed in stir is str. So we're going to say for I in str colon new stir plus equals I plus I. Now, new stir should be defined if we're going to add something to it. So we need to add a new initialization here, a new stir, and we should set it to an empty string because we want to be able to add it to, have it start at nothing. And then we want to return it to the caller. So we'll return new stir. And then you say go, and it will run it against a bunch of tests. And it'll show you what it expected and what it got. And the green obviously means it's okay. And then you can say, well, is there a better way to do this? Could I, for one thing, I could say 2 times I because strings, I'd say I times 2. Multiplication of strings is replication. It makes copies of it. You can sort of think, is there a better way to do this? I'm not thinking of anything offhand, but anyway, check these out. You can just go through them one after another, and they're really fun. I won't belabor that any more than I already have, but I think that's pretty much it for this week. Let me see where we are time-wise. About 6 minutes early. Anybody have any questions? If you have a question, feel free to jump on the audio. Sounds like a no. So if you have problems or questions, email me. Oh, one last thing. At the beginning of the class, I said, here's the second half. This is very flexible. So, I think week 5 and 6 probably should continue with being the core Python topics. But when I get into these 2 applied weeks, let me know if you see something you think is missing, or there's something you'd really like to learn about that you don't see there, or even a general applied topic that I'm not covering. I'm happy to just sort of tailor this as much as I can to your needs. So send me email if you have any thoughts on that. And other than that, we are done. 5 minutes early. Thanks for coming.
Thank you, Mark.
You're
Bye.
welcome. Bye.
Thank you, Mark.
You're welcome. Thanks for coming.
We'll do more practice and we'll get back to you if there's any question.
Okay.
Thank you, Mark.
You're welcome.
Thank you, Mark.
You're welcome. Thanks for coming.